Okay, so here we are, Chapter 1, Lesson 7, and what you're going to see with Chapter 1, Lesson 7 is that we're not learning anything new. Yay! Okay, what we're doing is now we're taking everything we know about rates and ratios and we're applying them to story problems. So this is amazing because all we're doing is all of the knowledge that we've been gaining throughout this entire chapter, we actually get to completely utilize it in real-world problems. So we're going to jump right on into page 72. So make sure your book is open to page 72. I'm going to minimize myself and jump right on up to the screen, and we're going to go ahead and get started. Okay, so we're going to take a look at some of the examples that are here. And actually, we're just going to look at one example that's complete, and then we're going to do one that is not complete. So on page 72, I want you to take note of this question right here. Okay. Number 1, it says Heritage Middle School has 150 students. 2 out of 3 students in Miss Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So here we are actually using the ratio problem. So you're going to see that there's 150, I'm going to teach you 2 methods. Okay, 2 methods that you've already seen before, and you choose which method works best for you. I prefer the equivalent ratio, the equivalent fractions, but some people like to draw a diagram. So if you're talking 2 out of 3, notice how they had drawn the bar diagram, and up at top they have a total of 150 students. If I have a total of 150 students and I'm dividing them into groups of 3, because it's out of 2/3, that means that 50 would be in each of these boxes. So right here, this is 1/3. Okay, this would be 2/3, and if all of them preferred it, it would be 3/3. Since I'm only talking about 2/3, that tells me how many people. Well, 50 plus 50 is 100. So we're saying 100 students prefer gel toothpaste based off of this bar diagram. Now, for me, I like to use equivalent fractions and equivalent ratios because we're going to actually be working on fractions, decimals, and percents starting in the next chapter, and we see them throughout the entire 6th grade. And then you see them in 7th grade and 8th grade, so I like to just go ahead and use that one. But again, I always say, you do what makes sense for you. So if we're talking about 2/3, and we know that the total is 150, okay, this is where we figure out how we get from like this denominator to this denominator. When we see the 3 and we're trying to get to 150. We know that if we multiply 3 times 100 or 3 times 50, that's going to give us 150. Whatever I do to the bottom denominator, I must do to the numerator. I have to do to the top. So whatever I do to the bottom, I have to do to the top. I multiplied by 50, so I have to multiply by 50 to the top, which is going to give me 100. So it's the exact same answer. Okay, let's take a look at... Go over, turn your page, and we're going to actually just solve some problems that are right here. So on page 73, let's take a look at A. Again, make sure you're writing exactly what I'm writing. In a survey, 4 out of 5, that's what I meant to say. 4 out of 5 people prefer creamy over chunky peanut butter. I don't know why I really like chunky, but whatever. Apparently I'm like the oddball out, because only 1/5, out of every 5 likes chunky, but that's okay. There are 120 people shopping at their grocery store. Okay, so there's a total of 120 people. Do you see how I can already set up my ratio table or I can set up my equivalent fraction? So it says use the survey to predict how many people in the store would prefer creamy. So I have to figure out how I get from 5 to 120. Now, if you're like, man, I just don't know off the top of my head, this is where we would take 120 and divide it by 5. We know that goes in twice. We subtract 2, that goes in 4, which would leave us with nothing. So that means that I am multiplying by 24 because 5 times 24 is 120. Whatever I do to the top, I have to do to the whatever I do to the bottom, I have to do to the top. Whatever I do to the top, I have to do to the bottom. So it doesn't change. So if I multiply the denominator by 24, I have to multiply the numerator by 24. So I'm going to come over here. 24 times 4. 4 times 4 is 16. Oops. going to carry the 1 for a second. It wasn't working. 4 times 2 is 8, plus 1 is 9, and I get 96. So 96 people in the store would probably prefer Chunky based off of this survey right here, if there were 120 people in the store. Okay? All right, let's take a look at B. A survey found 12 out of 15, whoops, I was like erasing at that time. What in the world? Okay, 12 out of 15 people in the United States prefer eating at a restaurant over cooking at home. Lord, let me tell you about Mrs. Horner. I love to go out to eat, and my favorite place to go out to eat is Jose Peppers. Oh my gosh, I love their espinaca sauce. Okay, back to math. I think I'm going to go there tonight. Today's Tuesday, although you're probably not watching this when it's Tuesday, so it's Taco Tuesday. So I'm probably going to go there and eat espinaca sauce. Espinaca cheese. Espinaca dip. I don't know. Whatever it is. So delicious. Okay, cheese dip. There you go. All right, so I would prefer to eat out anytime rather than cooking. Too much of a mess. Okay. If 400 people are selected eating at a restaurant on the survey, how many people took the survey? So 400 people prefer to eat out. So this was the total, and this is how many people prefer a restaurant. Notice I shortened that up. So 12 prefer to eat at a restaurant out of 15 total. So notice how I had to put my numerator as 400. Because that is who prefer to eat at a restaurant. So this is still at a restaurant. Okay? It would just be like setting up our little bar diagram. Very similar. So restaurant in the total, you'd have 12 out of 15, and then you would have 400. Okay, so 12 times what gives us 400? Well, man, that's tough. So I'm going to scale back and scale forward. Okay, when I look at 12 and 15, and I'm going to bring it over here, when I look at 12 and 15, I know that I can divide each of those by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. Now, doesn't that look easier to try to get to 400? Yeah. 4 times what gives me 400? 4 times 100. So if I multiply the top by 4, I know that I have to multiply if I multiply the top by 100, I know that I have to multiply my bottom by 100. 5 times 100 is 500. Therefore, 500 people took the survey. Okay? 500 people took the survey. All right. Let's take a look. Down. There we go. Sorry. It's like kind of going a little crazy. There we go. Okay. All right. So, taking a look at this, you're going to see that we are now working on rate problems. Okay? So, the Millers drove 105 miles on 4 gallons of gas. 105 miles on 4 gallons of gas. At this rate, how many can they drive on 6 gallons? So this is miles, and this is gallons. So just so that we can remember, we're going to kind of make it like a ratio table, okay? So we can make it like a ratio table. It'll make it easier, okay? But I want to know, and I'm just going to put a couple of extra spaces, okay? I want to know what can I do when I get to 6? How do I get from 4 to 6? Well, the first thing we should do is we should find a unit rate. Okay, so let's try to get it to 1, which means I'm going to divide by 4. Now, I don't know about you, but I don't know off the top of my head what this answer is, so I'm going to work this problem out. We want to get it to a unit rate first. So I know that that goes in twice. That's 8. I'm left with 25. I know that that can go in 6 times. That's 24. I'm left with 1. I'm going to add a decimal point. Okay. I'm going to bring my 0 down. I know that that can go in twice. That's 8. Subtract, then bring down, and I know that that goes in 5 times. Okay? And then I know that it's going to end up at 0. So I know 26.25 is what it is for 1 gallon of gas. I can go 26.25 miles. So now that I know that, how can I get from 1 to 6? I can multiply by 6, which means I need to take that 26.25 and multiply that by 6, which they have done right there for us in this example. So I know that I can go 157.5 miles on 6 gallons of gas. Okay? All right, let's practice this one right here. It says there are 810 calories in 3 scoops of vanilla ice cream, but I want to know how many there are in 7 scoops. So the first thing I need to do is I need to find that unit rate, okay, which means I've got to get a denominator of 1. And in order to get that denominator of 1, I need to divide by 3. So 3 divided by 3 is 1. 810 divided by 3, I'm going to come over here and work the problem out. So 2, 6, 1, that goes in 7, 0. So 270 calories in 1 scoop of ice cream. Now I want to find the equivalent rate from this. So how do I get from 1 to 7? I multiply by 7. How do I get from here to here to figure out 270 times 7, 0, 49, 14, 15, 16, 17, 18 gives me 1,890 calories in 7 scoops of ice cream. So 1,890 calories in 7 scoops of ice cream. Eeh. I don't know about you, but it's a good thing I work out in the morning. I do like some ice cream. All right, let's take a look at some more problems. So go ahead and turn to the next page. Okay, and let's take a look at some of the guided practice. Okay, so number 1, out of 30 students surveyed, 17 have a dog. Based on this results, predict how many of 300 students have a dog. So you have those that have a dog and the total. So out of 300 total, 17 had dogs. Okay. Now, we're still talking about the total number of students, which is 300. So how do I get from here to here? I multiply by 10, which means I have to multiply my top number by 10, which gives me 170 students, because I take 17 times 10. So 170 students out of 300 students have a dog. All right, if 1 out of 12 students at a school share a locker, how many share a locker in a school of 456? So 1 out of 12, so this is shares a locker. This is total students, and this is shares a locker. And then we have a total of 456 students. How do I get from here to here? Well, I'm probably going to have to start with dividing, because I don't know that off the top of my head. So 456 divided by 12. I know that that can go in 3 times, which is 36. And when I subtract, I know that's 15, so that gives me 9, 96. And I know that 12 times 8 is 96. And so I know that I am multiplying by 38. So I'm going to come up here and I'm going to multiply that number by 38. So of a school of 456 students, 38 students share a locker. Okay. I am going to have another practice with some other problems. If you need some more practice problems, then you can jump onto the other video and do some more practice problems with me. But if you feel like you got it, then you're good.